What happens when you try to generate video in real time, but your model insists on processing every single frame sequentially? We hit a time chain bottleneck, slowing even the most powerful AI systems to a crawl. Timestep-Forcing Pipeline Parallelism, or TPP, changes the rules by turning the timeline itself into a parallelism. To understand TPP, we first have to look at how generative models usually think. Whether it is a transformer or a diffusion model, they are bound by sequential dependency, meaning step 2 cannot happen until step 1 is done. This creates a bottleneck, where the total delay grows linearly with every single step added to the process. Traditional methods try to solve this by cutting the model layers into chunks, but that fundamentally fails to break the sequential chain. TPP takes a different approach by assigning distinct timetabs or token slices to distinct processing units. This creates a true assembly line, where multiple stages of the generation process happen at the exact same moment, across different devices. Here is the logic that drives this assembly line. Instead of a complex global exchange, each device enters a lockstep cycle, where it receives a latent tensor, computes its assigned timetable, and immediately hands the result off to the next device. Notice how the key value caches stay local, avoiding the heavy bandwidth penalties we usually see in distributed training. Now let's examine how we map this logic to physical hardware and the speedups we achieve. In a real-world setup like the live avatar system, we map one processing unit to exactly one denoising step. Data blocks cascade through this chain of devices, maximizing parallel occupancy once the pipeline is full. Because only the compressed latent tensors move between devices, we eliminate the need to transfer massive activation data across the wire. The impact on throughput demonstrates why this architecture matters. Where a sequential diffusion model might struggle at 5 frames per second, TPP accelerates this over 4 times to nearly 21 frames per second. By ensuring the system throughput is determined only by the slowest single step, we unlock real-time capabilities that were previously impossible. TPP represents a fundamental shift from optimizing batch size to optimizing the timeline itself, making real-time generative video a tangible reality. Head over to emergentmind.com to learn more about these architectural innovations.